Kita sekarang sampai ke las gas ya, atau gas arc welding. Mungkin lebih tepatnya las busur gas ya. Pada pembahasan sebelumnya dibicarakan bahwa sumber panasnya ya berasal dari reaksi kimia ya, tepatnya reaksi endotermik, eksotermik ya, yaitu pada proses thermite welding ya. Sekarang kita mendiskusikan las busur gas atau las gas, disebut singkat seperti itu. Tentu berbeda dengan las thermite. Las gas ini sumber panasnya berasal dari nyala gas ya yang terbakar ya. Ya, dan karena proses pembakaran selalu melibatkan oksigen, maka biasanya namanya oxy-fuel ya. Jadi mungkin ada istilah-istilah yang kadang perlu diluruskan ya. Yaitu yang pertama las busur gas. Ini disebut las gas ya di sini. Ini aslinya bahasa Inggrisnya adalah gas arc welding atau mungkin las busur gas ya. Nanti las busur gas soalnya ada gas metal arc welding itu yang las busur gas ya. Karena itu ini bahasanya agak bulat ya kalau di bahasa Indonesia kan. Ya. Ini mungkin saya kasih tanda tanya saja ya. Karena nanti ada las gas metal arc welding yang biasa diterjemahkan sebagai las busur gas ya. Oke, tapi intinya ini bahan bakar panas ya diperoleh dari pembakaran gas ya. Ya, ini yang membedakan dengan las thermite yang panas diperoleh dari reaksi kimia ya, reaksi eksoterm kimia. Dan las busur listrik ya dibedakan dengan las busur listrik yang panas diperoleh dari busur listrik. Kemudian juga dibedakan dengan las sinar energi tinggi ya, atau high beam welding. High density beam welding. Oke, ada nama lain ya, karena proses pembakaran dari gas itu selalu melibatkan oksigen, maka ada yang menyebutnya oxy-fuel ya. Ya. Kemudian karena paling sering digunakan fuelnya ini adalah asetilin, maka namanya oxy-acetylene welding ya, atau disingkat OAW ya. Ini OAW itu nama resmi dari AWS. Oke, saya baca sebentar. Proses pengelasan secara umum meliputi semua operasi pengelasan, proses pengelasan gas ya, pengelasan yang menggunakan bahan bakar gas yang dikombinasikan dengan oksigen sebagai media pemanas. Media pemanasnya adalah bahan bakar gas yang bereaksi dengan oksigen sehingga namanya oxy-fuel. Salah satu keuntungan yang jelas ya dari proses pengelasan gas adalah alatnya yang sederhana, portable, dan tidak mahal. Tadi sudah dijelaskan ya, gas asetilin ya, C2H2 adalah yang paling banyak digunakan dalam proses pengelasan gas. Sehingga pengelasan gas sering disebut dengan pengelasan oksiasetilin. Kadang juga digunakan fluk ya. Penggunaan fluk bisa diperlukan, bisa tidak. Tergantung derajat perlindungan las yang dibutuhkan pada pengelasan. Sebelum kita berbicara tentang teori las gas lebih jauh, saya ada 6 video ya yang berbicara tentang las gas. Ada baiknya disimak dahulu oleh para mahasiswa untuk membuka wawasan sebelum kita berdiskusi secara lebih dalam. Ada ya 3 video menarik yang berhubungan dengan las busur gas ya. Yang pertama ini adalah lebih berat ke teori kimianya ya, tentang oksiasetilin ya, gas oksiasetilin. Kemudian yang kedua, ya ini agak panjang video yang pertama itu ya, 11 menitan. Kemudian video kedua yaitu tentang teori ya, dasar proses las busur gas ya, las oksiasetilin. Ya ini ada ya teori mengajar di kelas lah. Ya, videonya pendek 5 menit saja. Kemudian video yang terakhir ini ada slide share animasinya ya. Jadi sedikit lebih baik dibanding video yang kedua ini ya, yang ketiga. Mari kita saksikan video-video tersebut yang alamat asli linknya ada di sini dan bisa dilihat sendiri oleh mahasiswa ya. Ini video yang pertama.
On the very first day of my chemistry class, I performed this demonstration, combustion of acetylene. Now, the purpose for doing this is to ensure that my students will be good observers. And so what I'm stressing is that they use as many senses as possible. Now, the demonstration is going to involve creating some acetylene gas in this thick-walled flask, which is also called a filter flask. I'll be using chunks of calcium carbide. But since I will do this very rapidly, and it's rather small, I'm going to go to the diagram up here on the board so that you will understand how I'm going to present this. So this represents our thick-walled flask. What I'm going to do is put water into the bottom of the flask. I'm going to drop in some chunks of calcium carbide, and then I'm going to cork the flask and very quickly bring a match up to the sidearm. And then we'll observe what happens. So let's go back, and I want you to put on your safety glasses while we start measuring out our reactants. Now, you may use tap water for this, and the amount is not super critical. So just so that you have a couple of centimeters in the base of the flask. I'm going to put the flask behind the safety shield. Now, my calcium carbide chunks are these gray chunks, and I'm going to select 3 medium-sized chunks, drop them into the flask, and then bring the lit match. Because of the speed at which I do this, I want to have the matches already out, have my corks ready to go here. Now, always have 2 corks, because sometimes you can't find the first one in a timely fashion. But what do the students always say? Do it again. So this time I'm going to leave what's already in there, and I'm going to add even more calcium carbide. And some of the students are a little bit anxious about this because I'll be saying things like, well, do you think it's going to be bigger explosion? Think it's going to be louder? What's going to happen here? So I just take my time, drop in a bunch of chunks of calcium carbide, leisurely put the cork in there, and bring the match. No explosion. But what we do have is combustion. And I want to quench this reaction, so I'm going to bring a wet paper towel up to the side here to put out the flame. And then eventually I'm going to have to discard this, but I do want to stop the reaction. So what I'm going to do is pour off most of the liquid into the speaker. Now, by the way, let me mention something about calcium carbide. You saw how easily it reacts with the water in the flask, so it's really important that you don't touch it because you have moisture on your hands. Also that you seal it up tightly afterwards because, again, moisture in the air will react with the calcium carbide. Now we're going to go back up to our board and talk about the reaction. Now, with my students, what I would do is ask them, okay, in terms of gases, is there any gas in this flask before I even add the water and the calcium carbide? And ideally, they would say, well, sure, there's air in the flask. Okay, what gases are in air? And maybe you'd get that nitrogen and oxygen as the 2 main components in air. And then it's like, which one's in greater abundance? Does anyone know what that ratio is? And that's kind of a tough question on the first day of chemistry. But at least maybe some of them will know that there's a lot more nitrogen than oxygen. And so at this point, I can take my glasses off while I'm at the board here. And I'll say, all right, to represent oxygen, I'm going to use this model right here. And I tell them how oxygen hangs around in 2s, so that's O2. And the purple is going to represent nitrogen. But since the ratio is approximately 4:1, let's put 4 nitrogens in here and 1 oxygen. Now, there's of course air outside the flask, right? So let's put some nitrogen and oxygen hanging outside the flask here. Now, what happens when I add the calcium carbide in the water? I produce acetylene gas. And we're going to use this model to represent acetylene gas. Acetylene is C2H2. And with my students, I'd actually talk about those symbols. Now, we'll put a couple of acetylene molecules in here. And then I'll say when I bring that lit match up to the sidearm, the oxygen and the acetylene can react. That's what combustion is, reaction with oxygen. And it's going to produce even more gases. Those gases are going to expand rapidly. They're going to push out the cork. And then air rushes back in. And that's why we get an explosion. So what I'm doing is I'm explaining what an explosion is all about. It's a rapid expansion of gases followed by air rushing into that space. Now, why did we get a different result when I let the reaction go longer? Well, let's go back and put our cork back in the flask. And now, remember, I added a lot more calcium carbide and I waited. And that waiting is what's really critical. Because when we wait, we produce more and more acetylene. But what's going to happen to the air that's in the flask? As we make more and more acetylene, those nitrogen and oxygen molecules are going to be pushed out of the flask. And so when I bring the match up the second time, all I've got is acetylene in the flask. There's no oxygen with which it to react. So what happens is we still get combustion, but it's happening right here as some of the acetylene gets to the sidearm and the oxygen's out in the air. Now, are we still producing gas products? Yes. But when those gas products rapidly expand, they're rapidly expanding into the room. And when they rapidly expand into the room, there's no way that we're going to push everything out of the room gas-wise and have the air rush back in and get that explosion. So the difference is where is the combustion taking place? Now, this reaction is interesting to look at, but does it have any application? So let's look at a previous application here. This is a calcium carbide lamp. And this actually is one that was used by one of my colleagues who was a cave explorer and a spelunker. And it operates on the same premise, because what you do here is that you put calcium carbide into the base of this lamp, and then you put water into the top. And there's a device here that regulates the flow of water. So the water drips in, produces the calcium, produces the acetylene, and it comes out here. And then there is a flint so that you can actually light the acetylene. And interestingly enough, even though nowadays we would be using battery-operated lamps, this is lighter weight in the grand scheme of things. Now, these calcium carbide lamps have also been used in the very beginning for headlights in cars up until maybe even the 1930s. And I also read about, and I'm a bicyclist, and I also read about bicycle lamps being originally out of a calcium carbide lamp. So that's a good application of this reaction. Now remember, this is the first day. So I'm not going to go through a lot of chemical reactions with them in terms of equations. But you can revisit this actual demonstration when you do get to chemical reactions. So I'm going to go over to the easel here, and I'm going to show you the equations that are involved. Now remember that there were two things happening here. We had first to prepare the acetylene, and that was by using calcium carbide, CaC2, reacting it with water, getting our acetylene, C2H2, and calcium hydroxide is an additional product here. So if you want to talk about acid-base chemistry sometime later in the year, you can also mention this equation. Now the actual combustion of acetylene is shown here. And that's reacting the acetylene with oxygen to make carbon dioxide and water vapor. Now, this is a clean combustion. And I think we all noticed that this was not exactly a clean combustion. That is, we saw some black soot being produced as well, and that is carbon. And so you do get additional incomplete combustion going on. But with my students, when we would be doing balancing equations, I'd focus on the clean combustion, but you could also talk about combustion that isn't clean. And of course, with concerns in the environment, that's a major issue as well, with burning anything that's made up of carbon and hydrogen. Now, I do want to summarize here. Remember, first day of class. And even though we're not doing a lot of equations at all, though we're talking about formulas, it's a real good opportunity when that student walks in the door and says, well, are we going to blow something up today? And you can say, as a matter of fact, we are.
Oke, itulah ya teori tentang sedikit kimia dari gas oksiasetilin ya. Asetilin, gas asetilin. Oke, ini berikutnya adalah teori gas welding, oksiasetilin welding ya. Kita ikuti videonya sebentar ya.
Hello student.
On the very first
Today we are going to learn what is high pressure welding and what is low pressure welding in oxyacetylene welding process. Okay. There are two systems of oxyacetylene welding depending upon the manner in which acetylene is supplied for welding, in which process acetylene is supplied. Number 1, high pressure system means high pressure welding. Number 2, low pressure system or low pressure welding. Acetylene is supplied either from generator or it may be purchased in metal cylinder. Here generators means acetylene is produced by reaction of water with calcium carbide in plant, and acetylene is supplied directly from generating plant. Okay. Oxygen is always supplied from metal cylinders. Okay. Now, what is high pressure system? What is high pressure welding system? In this method, both oxygen and acetylene are obtained for use from high pressure cylinder. Acetylene and oxygen both are used from high pressure metal cylinder. Okay. Now, what is low pressure system? What is low pressure welding system? In this method, oxygen is taken as usual from a high pressure cylinder. Oxygen is taken always from high pressure cylinder, but acetylene is generated by the action of water on carbide, usually calcium carbide, in a low pressure acetylene generator, in a low pressure acetylene generator plant. Reaction is calcium carbide plus H2O equal to calcium hydroxide and acetylene. This is low pressure acetylene generator from the plant. Okay, it is clear, my student? Thank you.
Ya, ini video yang terakhir sekarang ya. Ada sedikit animasinya.
Gas welding. Gas welding is a welding process that melts and joins metals by heating them with a flame caused by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding, due to its high flame temperature. In this video we will cover the following about gas welding, equipments of oxyacetylene welding, working, advantages, disadvantages, and applications. If you are new to this channel, click on the subscribe button and turn on all notifications so that you will never miss an update. Gas welding equipments. Cylinders. In gas welding, there are two cylinders. One is a fuel gas and is of maroon color. The second one is oxygen gas and is black color. Oxygen and acetylene are stored under pressure in a steel cylinder. They are seized by the amount of oxygen or acetylene that they hold. Cylinders should always be secured and used in the upright position. When a cylinder is not being used, the valve cap should always be in place. Oxygen cylinders. They contain compressed oxygen at high pressure, that can be as high as 2200 psi. All cylinders have valves and are fitted with a screw-on steel cap that protects the cylinder valve when the cylinder is not in use. Acetylene cylinders. These cylinders contain acetylene under pressure, made of steel and have cylinder valves. The cylinders contain porous filler material, which is fitted with acetone, that allows the acetylene to be safely contained in the cylinder at 250 psi. Acetylene should never be used at a pressure that exceeds 15 psi, as it becomes highly unstable, which depending upon the condition could cause it to decompose and explode. Pressure regulators. For welding, the oxygen and acetylene are required at low pressure, but in the cylinders, they are filled in high pressure. So a pressure regulator is required to control the pressure of oxygen and acetylene before reaching the mixing chamber. Torch. The torch consists of the handle, oxygen and the fuel gas valves, and the mixing chamber. Inside the handle, there are tubes through which the oxygen and fuel gas flow. Mixing chamber. In this chamber, oxygen and fuel gas are mixed. In this mixing chamber, the ratio of oxygen and fuel gas is mixed according to the type of flame required, such as neutral, oxidizing or carburizing flame. Control valves. There are two control valves available in this torch. One is for the oxygen, and the second one is for fuel gas. These control valves are used to control the flow of oxygen or fuel gas to the mixing chamber. Gas hoses. The gas hoses are used to transfer oxygen and fuel gas from the cylinder to the welding torch. These hoses are color-coded for easy identification. This color coding varies from country to country. Nozzle. The mixture of oxygen and acetylene comes out of this nozzle. The mixture of these gases comes out in pressure from the nozzle and then is ignited by the striker. Goggles and gloves. In gas welding, goggles and gloves are used for the safety of the operator who does welding. They are used to protect the hand and eyes of the welding operator from radiation and heat of the flame. Working of gas welding. At first, all the equipment of gas welding is fitted properly and carefully. After that, a regulated pressure of gas and oxygen supplied to the torch where they are properly mixed. The mixture of fuel gas and oxygen is then ignited by the striker. Then the flame of the torch is controlled by different valves present in the welding torch. Based on the type of flame required, the valves are operated accordingly. If the neutral flame is required, then both the valves are opened equally. If the oxidizing flame is required, then the valve of oxygen is opened more. And if the carburizing flame is required, then the valve of the fuel gas is opened more. The flame is set as neutral, oxidizing, and carburizing based on the metal, its thickness, and some other welding conditions. If you want to know about types of flames in detail, the link will be provided in the description of this video. After that, the flame of the welding torch is moved along the line between the two metal plates. Along with the metal plates, a filler rod is also used, which is used to create a pool of molten material that will fill the gap between the two metal plates interface. The filler rod is moved along with the flame. The filler rod is kept at an angle of 30 degrees to 40 degrees, according to the welding technique being used. After moving the flame and filler rod along the line of two metal plates interface, the two metal plates join together because of the melting and solidification of metal plates interface and the filler rod. Advantages of gas welding. 1. It is easily portable. 2. It is very less expensive and very affordable. 3. It can be easily maintained and repaired. 4. It is a very simple piece of equipment. 5. It is self-sufficient and does not rely on other equipment. Disadvantages of gas welding. 1. The metal joining rate is very slow, so the welding speed is low. 2. A skilled operator is required to operate this machine. 3. The power density is low. 4. The heat affected zone is large. 5. Gas welding is not recommended for welding reactive and refractory metals like titanium and zirconium. Applications of gas welding. 1. Used for joining thin materials. 2. Used for joining ferrous and non-ferrous materials. 3. Gas welding is used in sheet metal fabrication. 4. It is used in aircraft industries. If you like this video, click on the like button, and if you are new to this channel, consider subscribing this channel to get all the latest updates.
Oke, demikianlah 3 buah video tentang oxyacetylen welding. Mudah-mudahan menambah wawasan dari mahasiswa. Ada ya 3 video yang cukup panjang ya dan menarik dikerjakan di workshop atau di bingkilnya dari proses las oxyacetylen ya. Yang pertama ini ya berbicarakan tentang ya faktor keamanan, bagaimana mengatur regulator, menangani torchnya ya. Terus proses pengelasan yang dasar ya. Yang kedua ini versi panjang, isinya hampir sama saja. Ya, bagaimana mengatur tangki oksigen dan asetilin, kemudian peralatan keamanan, menyalakan busur, kemudian membersihkan ya, bagaimana mematikan torch dan mematikan tangki. Yang ketiga ini video pendek tentang jenis-jenis nyala ya. Nyala netral, nyala oksigen, dan nyala asetilin. Yang video pertama ini nggak terlalu panjang, 12 menit. Yang kedua ini agak panjang ya, 25 menit. Dan kemudian video yang terakhir ini pendek, sekitar 2 menit.
Setting a neutral.
Hi everyone, today we're going to do some oxyacetylene welding. I'm going to show you how to set up your regulator tanks, how to safely use your torch, and how to do some basic fusion welding with some flat bar. This is just regular steel. So first off, setting up your tanks, we've got 2 here. We have an oxygen tank and we have an acetylene tank. I have a little rhyme that I follow for all of these steps. It's always going to be A before O, acetylene before oxygen, or up you go. Don't ask me why, but it's going to help you remember every single step. So before I get started setting up my tanks, I need to make sure that my torch and everything has been set up correctly. We need to make sure that the tip, there's a tiny little hole here. We need to make sure that the tip is clean. It's hard to see. You need to make sure the tip is clean. If you do need to clean it, and you can tell once you actually start welding, you can use a tip cleaner. Tip cleaners look something like this. You need to pick the right size for the one that fits in that hole. First, we're going to do the acetylene first. We're going to open up the main valve here half a turn. So if this is my start, I want it to get to here. And I've drawn a little line here to help remember. Half a turn. Now the last person who used this did not purge the valves, but usually when you get to it, let me just purge that valve for a second. Release the pressure on my regulator. There we go. This is basically how much fuel is left in the cylinder, and this is how much pressure will be coming through. So in order for me to increase pressure that is going to be coming out of my torch, I'm going to have to adjust the regulator. I'm going to open up the knob on my torch handle for the acetylene or the fuel. Just open it up. Don't worry about how big it is yet. And I'm going to adjust the regulator here. I'm going in the plus. You can see plus or minus. I'm going plus, and I'm going to increase it to about 6 psi. There we go. We're at 3, 4, 5, 6. If you look very closely there, and you can hear the acetylene actually coming out. Go ahead and turn off your knob. This one is set and ready to go. Next, we have our oxygen tank. We need to adjust this till we have between, I'm going to say 5 and 10 psi coming out of this. We're going to open this valve all the way until it stops. We're going to take our torch handle, open up the oxygen, adjust the regulator until we have between 8 and 10 psi. It's hard to see the numbers, but we just need that little valve needle to show it just a little bit. Right there, that's good. Turn off your torch valve. So if you look closely, you can see that the needle on the left is just open a little bit. And down on the acetylene, it's around 6. Let's zoom in there a little bit. You can see that the PSI is just about 6. If you look on the left dial, you can see that there's a red zone. Do not push acetylene past 15 psi. Next, you need to have some sort of eye protection. We're going to be using a number 9 screen here. This allows it to protect your eyes and your face from the heat, mostly your eyes, so that your eyes don't hurt while welding. Welding with just bare eyes is going to hurt for a while. You need to have a set of gloves ready. We're using leather gloves here to protect from burns. And I've got pliers here to pick up hot material after we've been welding. If you pick up hot material with bare hands, you're going to get all blistery. I'm going to set up my 2 pieces of flat bar here with a slight gap in between. And I'm using fire brick to prevent my table from getting hot, and fire bricks will not explode when heated or anything. So now that I have my metal set up, I have my torch all ready to go. All I have to do is open my acetylene valve just a little bit, or fuel valve. This one's using acetylene. Open up just enough that you can feel it on your hands, or you can put it up in your ear and actually listen. I'm wearing these wicked glasses. Just enough to feel it. Take your striker, hold it on a slight angle beside here, and you get a nice sooty flame. All that black stuff is carbon. We want to get rid of that or it makes a big mess. I'm going to open up my acetylene valve until that black smoke goes away and I have a nice feathered flame. Delicious. If you're doing thinner material, you don't need as hot of a flame. In this case, we're doing 1/8 inch flat bar, so I'm going to open that up so I get a nice roar. I don't have a special number for this. Beautiful. Next, we're going to open up our oxygen and add some oxygen to this mix. Watch carefully what happens to the flame. Now if you look at it, it looks like we have 2 different cones here. We've got a very bright one, and we have a longer one here. Don't try to touch it, but you can get pretty close without feeling any heat. I'm not going to purposely do that though. All right, I'm going to adjust some more oxygen until that one cone gets nice and tiny. So here's just, I set the exposure on the camera down a little bit so you can see the 2 different cones. When you first have just acetylene, you've got that, add your oxygen, and you're going to see 2 different color flames essentially coming out. We've got a short bright one and a long one there. I'm going to add more oxygen until I have a very nice little cone that's maybe less than 1 centimeter long. All right, let's do some welding. So I have my flat bar set up with a very slight gap in between. I want to have a little bit of a gap to allow the metal to penetrate when it gets welded together. I'm going to start by tacking both ends, and then I'm going to do a fusion weld. To tack first, I'm going to heat it up. I'm going to hold my torch on about a 45-degree angle and kind of zigzag between the 2 pieces while concentrating on one area. If this is taking too long, you could increase the pressure and get more heat. What we're looking for is both pieces of metal to basically turn molten. You'll see it start to get shiny on both sides, and then those two shiny parts will join together into one puddle. Back and forth, let them join. There we go. There we have now a little puddle. I'm going to do the same thing to the other side. I've dropped the exposure on the camera so you can get a better look at what's going on here. So I'm holding my torch on about a 45-degree angle, zigzagging back and forth between the two pieces. I'll hold the torch on the other side so you can see better. And I want to get a nice little puddle going. Back and forth between the two. And I'm just hovering above the metal. I don't want the torch to actually touch the metal. Here comes my puddle. Should join soon. The two sides are getting molten. And I want those two little puddles there to become one. Wait for that moment. You can do little circles or zigzags. There it is. You see that? Now we have a nice little join. Now that I got my two sides tacked, I'm going to practice laying a fusion weld, which is basically taking that puddle and pushing it down the length of my joint here. Whether you're left-handed or right-handed, that doesn't matter. You got to find a way that works for you. I'm going to go in this direction and push my puddle that way. So I'm going to heat it up, get that puddle molten again. I'm holding my torch on about a 45-degree angle. Get that thing heated up, then I'm going to push the puddle. If I stay in one place for too long, once my puddle's going, I run the risk of actually burning through and burninating my metal. There we go. Keep your heat even on both parts of your metal. There we go. It's getting shiny. I'm waiting for that puddle to join. Here it is. I'm slowly going to zigzag and push forward with my torch. Now this flame is extremely hot. You're probably looking at over 3,000 degrees. Keep pushing that puddle all the way down the length of your metal. I do zigzags, but you could also do circle movements. I think that's personal preference. You can see that small molten puddle moving towards the end. You don't have to do giant circles. This is fairly thin material. We just want to work it down to the end. Don't go faster than your puddle. Slow down and let it go. Once you're finished your weld, turn off using the acetylene first, A, and then O. You can take this to a bucket of water or to the shop sink to cool it down. Be careful of the steam when this goes. Don't put your face directly above. Normally in welding, I'm not going to cool it down in a sink. I'm going to let it cool naturally. I don't want the weld to crack and become brittle. But when we're just practicing, I think it's okay. Once it's dried off, you can shine it up with a brush. And we can take a closer look at our fusion weld. It's nice and flat. I think this looks pretty good. If you flip it over, when you flip it over, you can see that the metal did not really penetrate too much through the gap there. If you wanted to get more penetration, you can put a little bit more space in between your metal.
Sekarang kita ke video kedua ya, yang agak panjang ini, mengenai las oksiasetilin ya di workshop.
Hey guys, welcome to another welding video. Today we're going to be going over a couple things that I forgot to mention during a previous gas welding video, doing oxyacetylene. I'm going to talk a little bit more in depth about the safety, change a couple things that I talked about last time as I've read a little bit more, and I think I've developed some bad habits over the years. I'm going to talk a little bit about the actual components inside your torch handle and a couple little tips here for that. So one of the first things that you want to check before you start welding, are your tanks secure? If you're using a mobile cart, are they going to fall over? Is this tank good enough? Is it going to hold it in place? When this thing's not moving, these aren't going anywhere, and it's enough to keep them in place. If they're attached to a wall, make sure they're attached securely with a chain. And then the next thing you want to do is double check that all the connections are tight. Now, these ones should have been tightened with a wrench. These should have been tightened with a wrench. These should have been tightened with a wrench, etc., etc. These ones here. These ones also have a built-in flashback arrestor. That's going to prevent gas from going the wrong direction, going back through here. You don't want to have oxygen go into the acetylene or acetylene go into the oxygen valve here or through that hose. So that's going to help with that. We've got one here, one here, one here, and here, so we are pretty much covered. Next thing we're going to want to double check is making sure that this has only been hand tightened. So there's different tips you can stick on to the end of one of these, and this should have only been tightened by hand. On the inside, there should be two O-rings. I've got one here and one here. Let's take a closer look at that. So I've got two O-rings. See if you can see that here. There's a small one here and a small one here. You want to double check that those are still in good condition. If one of those is to fail, there's a chance of gas escaping and going the wrong way. These ones are still good. It's a little bit dirty around here, but that's just, again, carbon. The actual O-rings themselves, they still feel rubbery, so that's good. What you don't want is for them to be hard and brittle, because then they are essentially useless and unable to create a good seal. I'm going to reattach that to here. I'm using a number 0 tip for this. This is kind of the most common one I use in the shop. We are rarely welding anything above 1/8" mild steel. Aim it the direction you like. Make sure it's tight for how you want to hold it. I like to hold it with this with my valves up here. Just easier access when I'm welding instead of being flipped upside down. Just hand tighten. If you use a wrench and you try to tighten this here, you risk damaging the O-rings that are under here. If you over tighten it, you're going to squish them, warp them, and that is going to cause something bad to happen. So that's tight, good enough, good seal. These ones, I've had it happen before where one of these was not tight enough, and I actually had flames shoot out here around the hose, close to where your hands are. It's very important to make sure that these have been tightened correctly. If you're able to loosen these by hand, something is wrong. Let's take a closer look at the tanks now. So you notice here, nothing's been set up yet. Both dials are down at 0, both my tank pressure and the actual gas pressure that's going to be coming through the hose. Before you do your setup, ensure that there is no pressure in this system at all. You don't want this basically hammering this with a big pressure. If you've ever been in an older home and the plumbing, sometimes you hear a knocking sound in the wall as you're turning, your hot water on or something. It's basically hammering into here, and that can damage the diaphragm and the other parts inside your regulator. So you want to make sure that that's been opened, all your pressure's been backed off, these are at 0. Perfect. Double check the same thing for your oxygen. On the oxygen here, I can also verify that these are both at 0, 0, nothing left in there. I can't feel anything. My regulator has been backed off, and now that means that this is safe to open. So let's go through the procedure of actually setting up the tanks correctly now. So now that I have verified that everything's down at 0 and this is safe to use, I'm ready to get started here. So I'm going to start with acetylene before oxygen. This is just a habit that I've developed. It doesn't really matter which tank you set up first, as long as your lines have been clear, they've been purged ahead of time. You don't want to have excess amounts of carbon or oxygen floating around inside your torch. So this is the way that I'm going to do it. The rhyme that helps me remember this and helps students remember kind of the order of operations is A before O or up you go. So acetylene before oxygen or up you go. If you do some of these things wrong, you run the risk of small explosions or popping noises and all sorts of things coming up. I've been doing this for about 15 years and I've never had anything dangerous happen, but I have developed some bad habits and I'm going to try to rectify those with this video. So step 1, we're going to open the valve to our cylinder here. This is the acetylene cylinder. We're going to open it half a turn. So if my line starts here, I want it to get to here. I'm can open that half a turn. The manufacturer recommends between half a turn, 1.5 turns, but I like to do half because it's really quick and easy to turn it off quickly in the case of an accident. So after you've done this, step 1, open your valve. Step 2, on your torch handle, open your acetylene or fuel valve, maybe about a half turn. After this has been opened, I'm going to adjust this. I'm going to turn it in the plus direction because I want to increase pressure. For me, we run it usually between 6 and 7. So I'm going to turn that handle and watch closely on this valve right here. And there we have 6. I can hear the acetylene coming out. I'll hold it up to the microphone so you can maybe hear it. Good. I'm going to go ahead and turn that off. So that was 4 steps. Number 1, open the acetylene valve on the cylinder half a turn. Step 2, open the acetylene valve on the torch handle about half a turn. Step 3, adjust your regulator to the desired pressure. This is based on the type of material you are welding or what your manufacturer has recommended. Step 4, turn off the torch valve on here. All right, let's move on to oxygen now. This one we're going to open the valve all the way. Again, I've double checked that these pressures are all down at 0. All the way open. And you can see my tank is running a little bit low, but there's still enough in here to do some welding. Step 2, open the valve on the torch handle for oxygen. And if you're not sure which is which, sometimes it's labeled, but usually just follow the hose. I've got a green hose here and a green hose coming out of my regulator. Open that up about a half turn. Increase the pressure on your regulator. We're going to go to about 10 psi. There we go. I'm at about 10. Turn off right here. So those 4 steps again. Number 1, open the tank here all the way until it stops. If you need a wrench to keep opening it, you're probably going to blow the thing up. Go until it stops with your hand, not breaking off the handle here. So step 1, open that all the way. Step 2, open your oxygen valve on your torch handle, about a half a turn. Step 3, adjust the pressure on your regulator to about 10 or whatever your manufacturer recommends. And step 4, close the torch handle on the oxygen. So now that you know how to set up the tank, it's time to start playing with some fire. Now, before I can actually do this, I need to make sure that I have all of my safety equipment. Recommended, wear a leather jacket. Why do you want to wear a leather jacket? Probably to protect your body from fire or flames or heat. I'm wearing my blue one here, but my students are usually wearing these ones. You probably want to make sure that you have some leather gloves. These are leather welding gloves. Inspect them, make sure they're not covered in oil or grease or anything flammable. You want to inspect and make sure they don't have any holes in them. Do these have any holes? Well, only one big one, so that one's okay. You're also going to want to protect your eyes. Staring at this with, just your bare eyes or a pair of clear safety glasses is not going to do it. I'm using a number 5 shade on my personal ones. We also have these ones, again, a number 5 shade. Or there's a full face mask that you could wear, again, a number 5 shade. So I've set up a little area here to do some practice welding. I'm using some fire brick. I probably don't want to use the sheet metal table that I've got here because the whole surface is going to heat up and warp. Again, use what you have, but be safe when you're doing this. I'm going to be using some mild steel here, and I'm going to do a little filler rod demo as part of this. Just a quick one, and then I'm going to show the shutdown procedures for the tank as well. Got my safety stuff. Again, my area has no grease in it. There's nothing that's able to catch fire accidentally. And let's go for it. So I have my torch. I have my glove ready. I typically don't put on my right glove until the flame is on because it's just easier for me to manipulate my striker. This is the only thing you should be using when you are lighting your torch. You should be using a proper striker. Don't use a lighter. Don't use matches. I've seen people use a cigarette to do this, but maybe let's just, for the sake of this video, stick to a regular striker. Let's see if we can show that a little bit better. Hard to hold it on this angle. Not a great striker. There we go. We got some sparks. Okay, I'm going to open up the fuel valve on here just a little bit. So we're going to do A before O. Open that just a little, as the French would say, un peu. So just a tiny bit, just to allow enough acetylene to come out. Hold my torch away from people, objects, small dogs, things like that. And I'm going to hold my striker on a slight angle, usually a 45-degree angle. If I hold it like this, where it's aimed straight into the cup, the flame can basically bounce back at me. So I'm going to hold this on a little bit of an angle, 45 usually. And I can get a small birthday candle style flame. Put my other glove on now, just easier for me to do it this way. I'm going to open up the fuel valve on here to my desired flame amount. As you can see, all this sooty black stuff coming off, that's carbon. I'm going to increase this, the pressure slowly and controlled. Now look at that flame. Something looks kind of funny there, doesn't it? It's splitting off in all sorts of different directions, making a bit of a hissing noise. Let's turn this off quickly and realize, why is this happening? So, my first guess is that the reason the flame was splitting into two places is because the tip is dirty. Now, if I look at it just visually, it's very sooty. I can't really see much. So it's a good idea to have a tip cleaner handy at all times when you're working so that you can fix those mistakes. You're going to pick the size of the tip cleaner based on the size of the hole here. So let's double check and pick the right one. I usually start with the small one and work my way up until it's kind of tight. Take your tip cleaner, stick it in the end. It's basically like a tiny file. It's going to help get rid of any little sooty spots or things that can be blocking here. All right, let's try that one out now. Let's light it up and see if it makes a difference. If this problem persists and it's not this that's causing that hissy noise, it could be something else that's wrong here. So I'm going to put my glove back on. Open my acetylene just a little bit. Again, I only want it to be like a small birthday candle. That was a very small one. Adjust it until the black smoke goes away. That is much better. So I've got a little bit of black smoke, but that's okay depending on the style of welding I'm doing. Make sure it's pointed usually close down to your workpiece. Now you see how it makes that all black? That's because it's still that sooty carbon. As soon as I add oxygen, it's going to be a much nicer flame. So I'm going to add oxygen very slowly, using that handle here. Oh, I just got a little bit on the table, my bad. Open this up, so we have a nice neutral flame. Now if you look closely at it, again, it seems to be splitting off into two places. That tells me I still need to clean the tip. So let's turn this off. This is the only time that you're actually going to do oxygen before acetylene. When you're actually turning off the torch, turn off your oxygen first to clear out any oxygen that's left in the system, and then turn off your acetylene. Now, it made a mess of my table, but that's all right. I'm going to allow this to cool down before I start working on it. So just let's fast forward until then. So now it's cooled down. Let's clean that a little bit more. It's much easier to do this when the thing is cold so your hands don't get burnt trying to do it. Get my gloves on and let's go for this again. Open your acetylene slowly. Hold that on a 45-degree angle. Open until that black sooty smoke goes away. Make sure it's pointed in a safe direction away from people. Add your oxygen slowly. We're going to get a nice neutral flame coming out. Now, there we go. So I've got a nice tiny little white tip there. That's a nice neutral flame. It looks pretty good. I'm going to be setting this up based on the thickness of my filler rod. So that's just under 1/8 of an inch. I'm going to say probably about a 3/32. And I'm going to tack it in two places and quickly do a little filler rod weld there. Let's get this lit again. So I'm going to start with a quick tack weld between the two pieces to prevent it from warping while I'm working. Let's get them both hot before I lay this thing on there. This first tack weld is not meant for strength, it's just to hold it in place. Another one over here. Once it gets a little bit cherry red, I'm going to just lay that across like a bridge. Melt that onto the two. There we go. Double check that one is on there. All right, there we go. All right, I'm going to get a puddle started and start doing some filler rod welding here. The reason that I have this gap, this is going to allow me to get some more penetration since I don't have the edges beveled or anything. Let's get that puddle started. I'm going to stay in that one space to make sure that it penetrates fully. There we go. Let's start adding some filler rod. Nice and slow movements. I'm holding my torch on about a 45-degree angle. trying to stay even with where I'm going between the two. Dip that filler rod into the puddle as you go. And I'm staying with the puddle until it moves forward by itself. This way I get the maximum amount of penetration I can. A lot of people think gas welding is a real waste of money, but I find this really relaxing and it really helps to teach the techniques, patience, that sometimes MIG welding, where you can just lay a bead in 5 seconds, doesn't show. So I don't want just a surface weld, so I'm staying with it until I visually see that it is filling up that crack by itself instead of just bridging on top. This way I get a lot of penetration, metal's going through all the way to the other side, not just on the surface. This one's not going to be the prettiest weld, but it's going to be strong. Going to touch up that last part. It's not going to be as strong as the other ones, but I want to get it lined up at the edge. Nice. So when turning off your torch, we used to do A before O. Now I'm going to do it a little bit differently today. We're going to do O before A. The reason for that is I want to make sure there's no oxygen left in this system causing any buildups or any of that stuff. So let's do oxygen first, then turn A off, or acetylene. And this is making sure that the system has been cleared of all gases in there. Let's take a look at this weld after it's cooled down a little bit. All right, to pick up metal, I'm not going to use my hand. I'm going to use a pair of pliers. I don't want to burn myself today. Let's flip it over and take a look at the penetration that I got. So if you look at the metal, you can see that the weld has penetrated decently through. I probably could have had a little bit more over on this side, but overall, that metal did make its way all the way through. That's going to give me a stronger weld. If I wanted to make this even stronger, I could probably just weld it from the other side, but I like to do single-sided welds just to double check, because you won't always have the opportunity. I probably went a little bit wider than I needed to with the bead, but this is again just to demonstrate some of the ways to do it. Let's go smack it with a hammer and see how strong it is. There's the back side. You can see the penetration. Not too bad. Could be a little better. Front side. There's our weld. Little bit messy. I was not being as consistent as I would like. But either way, we get to hit it with a hammer now. Did I say hammer? Yes, this is an 8-pound sledge from Princess Auto. Good deal. We'll see if it lasts more than a year. That's not too bad. That was 2 good hits. Let's hit it from the other side now. So let's see what broke first, the metal or the weld. Looks like it's just the metal that has bent. That is pretty good. So that's much better than the previous video where it showed the metal breaking right away. This one, the weld is still held up. Let's see how close I can get in focus. There we are. The weld is still holding. So by adding a little bit more of a gap in between my metal, using that filler rod and staying nice and slow, it allowed the metal to really penetrate, and that is shown based on the strength of the weld. I gave that 4 or 5 good hits with the sledge, and all it did was bend the metal. The weld is still intact. So now that we're all done welding, we need to make sure there's no gas left in any of these lines, either oxygen or acetylene. At the end of every day, I make sure that this is done. When I have students lined up one after another, we don't make them shut it down every time. But if it's sitting for more than 30 minutes, I make sure that the students at least purge the lines properly and turn the tanks off. That way we're not wasting any gas. The first thing that we want to do is take a look at this. And I'm going to show you the wrong way to do it first. If you just back off your regulator and then open the valve here, yeah, the regulator pressure drops, but look at this. There is still pressure left in between here. So ideally when you do this, that's not the order you want to go. The first thing we want to do is actually turn off the tank, release all pressure in here, and then back off the regulator. So let's set that back up again. We're going to turn off the actual tank first. This way, it's been isolated from anything forward here. We're going to open up the valve to release any pressure. This is the torch valve. Release any pressure that is still in the line. You're going to see both of these drop to 0. So third step, now you back off your regulator. So the order of operations for shutdown is the cylinder tank, or is it the cylinder valve first? Then open up the handle on your torch valve for acetylene. Let all the pressure purge from here, and then back off your regulator. Let's go on to oxygen and do the same thing. First step, we're going to close the valve on the cylinder. We're going to open the valve on the torch handle, again, oxygen. We're going to let all that pressure drop that was in that line. It is wasting some gas, but at the end of the day, I'd rather be safe than sorry. Back off the regulator. Turn off your torch handle. That way, there is no oxygen left in the system. That is all done and shut down. Now, for the longest time, I have always turned off acetylene before oxygen to turn my flame off. The reason that I've done that, and I was taught this way, is in an emergency situation, if you need the flame to go off right away, you turn off the acetylene first and it kills it. So if somebody's on fire, you drop something, you need to quickly reach over, and you can do that. You turn the flame off right away. The correct procedure that you see in most manuals, as recommended by a manufacturer like Victor, is going to be this way. So let me just get it lit here. Make sure those are all off. When it is lit, you've finished all your welding. So let's say you're using the torch, you're welding whatever here. Let's actually put some steel on the table. You've done your welding. You want to turn it off. Normally I do acetylene and then oxygen. Now the problem with that, there's still oxygen running through. You can hear that. Hold it up to the microphone. Hear that? We don't want that. We want to make sure there's nothing left in there. So ideally what the manufacturer recommends the manufacturer usually recommends turn off your oxygen first. So I'm going to go oxygen, then acetylene. That helps to purge the line of any excess gas that's in there. Again, personal preference. Usually follow the recommendations of your manufacturer, but in an emergency situation, I think it's okay to turn off acetylene first because it kills the flame right away. One more time. So, emergency situation, your hand is on fire, something bad has happened, hit that acetylene, it shuts off the flame right away. Don't forget to turn off your oxygen. Oh, by the way, don't open both of these and then try to light your flame. That's bad. Just don't do it. Always open only one at a time, which is acetylene first, or whatever your fuel is. There's my nice neutral flame. Manufacturer recommends oxygen and then acetylene. The thing I really don't like about it is when you're aimed at a table, it makes it all dirty. But in the book, that's what it says.
Video berikutnya ya sedikit tentang nyala 3 jenis nyala ya dari oksiasetilin ya. Kalau dalam bentuk video kita bisa melihatnya secara langsung daripada hanya menggambarkan.
Setting a neutral flame. Cutting. There are 3 types of flames: neutral, which has a balance of oxygen and acetylene, oxidizing, which has an excess of oxygen, and carburizing, which has an excess of acetylene. When you first light the torch, you'll have a yellow carburizing flame. As you add oxygen, the preheat flames turn blue, and you'll begin to see bright blue inner cones and lighter blue to white outer cones. At this point, the flame is still carburizing, which you can tell by the characteristic acetylene feather. Continue to add oxygen until the acetylene feather disappears and the outer cones become nearly equal with the inner cones. You will hear a slight hissing sound. At this point, depress and release the cutting oxygen lever. You may need to readjust the flame at this point. Typically, the flame becomes slightly carburizing and you'll need to add more oxygen. However, note that if you add too much oxygen, the outer cones disappear and the inner cones become pencil sharp and a loud hissing sound occurs. If this occurs, decrease oxygen flow. Note that alternate fuels produce flames with different intensities and shades of blue. To set a neutral flame, adjust the flame so that the feather just disappears into the inner cones. The inner cones will have a smooth radius and deep blue color.
Dengan berakhirnya 3 video pada slide ini, mudah-mudahan menambah lebih dalam lagi dasar-dasar pengetahuan mahasiswa tentang pengelasan oksi fuel, khususnya oksi asetilin.